Example 3, write each expression as a single logarithm in simplest form and then state any restrictions on the variable. So restrictions, this is an important one that we'll talk about when we solve again too. So an argument must be greater than 0. In other words, it can't be a negative number, so it has to be positive. So the argument must always be positive. If you think back to our log graphs, before we transform them, you have an asymptote on the y-axis and your domain was always x is greater than 0. So if I was to graph, for example, y equals log base 10x, the argument must be greater than 0. So we would say x is greater than 0. So we'll use the arguments greater than 0 when we find our restrictions on the following questions as well. Okay, so let's look at A. We're writing it as a single logarithm and then finding the restrictions. It doesn't matter which you do first, they're separate questions. So let's just write this as a single logarithm first. We'll start with what we know. We want to rewrite those coefficients as exponents. So I'm going to rewrite this one. Now, this has an exponent in here already. That's fine because if there was a number out here, that's how that would have come up there. So I don't have brackets around that yet. Nothing else is sort of changing there, but we'll careful of when you see exponents sometimes in the restrictions, or sorry, in the argument. Okay, so now we're going to write this as a single logarithm now with my base number of 2. So we'll start with x to the 4. Because this is a minus sign, this is going to go in the denominator now of x minus 1. And then this is plus, so this goes back up in the numerator. So I'm going to need brackets here. X squared plus 1. And I can put brackets there. I don't need it because I'm not putting anything else there. I do want to put brackets around the entire argument so it's very clear that that's all of the argument and not part of it is trailed off as something else. Okay, let's look at the restrictions now. So you have to look at each individual argument and then just see which one satisfies all the conditions. So if we look at the first argument, we're going to set each argument greater than 0. So we would say x is greater than 0. Let's look at the second logarithm. X minus 1 would be greater than 0, which would mean x is greater than 1. So if a number is greater than 1, it's automatically greater than 0. And then we're going to look at this one. X squared plus 1 is greater than 0. And when you go to solve for this, if you tried, you wouldn't be able to square root the negative. So that's because there are none. You're not going to have a number greater than 0. I like to picture that one on a graph. Remember, an x squared plus 1 parabola would be shifted up 1. So you'd have a graph like this. So it wouldn't have any x-intercept. That's why you're not being able to solve for x. So you don't have any restrictions on that variable. No matter what you substitute in for x, it will always be a number greater than 0, which makes sense too if you tried to substitute some numbers into that. So it's narrowed down to these. And as I mentioned before, if a number is greater than 1, it's automatically greater than 0. So therefore, you want to clearly state your final answer. X is greater than 1 satisfies all conditions. Okay, so I'm just going to put that clearly as my answer for my restriction.